our project is balancing congestion pricing and traffic costs to optimize road traffic efficiency. My name is Jianing.
I'm Chengyue.
I'm Pinchen.
I'm No.
I'm Sihan.
The background of our project is New York congestion pricing programs. It began on January 5th, 2025. Vehicles entering congestion relief zone. Local streets and avenues in Manhattan south of and including 60th Street are being charged a toll. The toll rule is it will be charged during the peaking periods, which is 5 a.m. to 9 p.m. in weekdays and 9 a.m. to 9 p.m. in weekends, and overnight periods, which was 9 p.m. to 5 a.m. in weekdays and 9 p.m. to 9 a.m. weekends. The next page is our hypothesis. Our hypothesis is congestion pricing can reduce the congestion in Manhattan, New York. With the quantitative indicator of congestion, including 6 parts. They are average speed, travel time, delay time, traffic volume, traffic density, and VC radio. The lower speed, the longer time, the higher volume, the higher density, and the higher VC radio will indicate heavier congestions. We will set a value that if these indicators exceeding this value, we will define it as congestions. And these are two support quantitative indicators. They are public transit usage rate. If there's an increase in public transport usage, it suggests fewer cars on the road and may indicate lower traffic congestions. And parking occupied rates. The lower parking occupied rates suggest fewer cars may indicate lower traffic congestions. And we will compare the trend in these key congestion indicators before and after the implementation of the congestion pricing, and separately compare the peaking and the overnight periods to assess time-specific impacts.
And for the details of hypothesis, as shown in the slide, we aim to regulate traffic flow distribution and enhance overall road efficiency through the congestion pricing strategies based on the speed or traffic volume. As illustrated on the right, using the subway as an example, the movement and placement of gates guide the flow of people and redistribute the number of passengers. Similarly, congestion fees and gates serve the same functions. And our hypothesis is that through the congestion pricing, we can quantify the driver's travel costs, including time costs, fuel costs, and electricity costs. And if the price and cost match, the driver accepts to pay the congestion fees and will continue driving on the original road. And if the fee exceeds the congestion cost, the drivers will choose the alternative routes, and thereby reducing the traffic pressure on main roads. And finally, we will find a balance point through the congestion fee settings to match the traffic flow with the road capacity, and reducing the congestion while ensuring the efficient use of road resources. And the next member will introduce the data sets of potential use.
These are the data we prepared. Most of these data come from NYC open data on the internet. From easy path readers, we can get the speed, time, and distance of the vehicles. This helps us analyze traffic dunes and assess the impact of congestion pricing on vehicle speed. Automatic traffic volume can help us understand traffic flow changes and provide the basis for pricing strategies. Park NYC records the price information of parking lots at different times and places. This will also become the cost of driving. Data from the traffic prediction dataset can help us predict peak hours of traffic flow and adjust pricing strategies based on the vehicle types. Next.
This part is the preliminary data visualization. So the first figure is the data visualization of the database mentioned earlier. which shows the relationship between the road congestion and the number of vehicles of various types. The map is the Google's real-time map. We will use the data from the database mentioned earlier to study the relationship between the road congestion and the vehicle speed as shown in this picture. Next. This is a pie chart of the public response to the congestion charge, and it can be seen from the chart that only 21% people will have no change in driving after the congestion charge. So it shows that most people would adjust their travel strategies due to the congestion charge. Next.
So based on our assumptions, the following are possible potential policies to strike a balance between traffic flow and roadway capacity. First, we can implement congestion pricing that adjusts in real time to traffic flow, encouraging drivers to avoid peak hours or overcrowded roads. Secondly, we can incentivize drivers to choose alternative routes by lowering the tolls or even giving them incentives so as to redistribute traffic flow more evenly. Thirdly, we propose to reinvest congestion charge revenues in smart infrastructure and public transport improvements to create a sustainable cycle. Finally, clearly communicating the cost of travel, including time, tolls, and energy consumption, can help drivers make informed decisions. These policies aim to improve efficiency, reduce congestion, and promote a more balanced use of road resources. And this is role contributions and questions for us. Thank you.